This week's lab is going to be all about naming chemical compounds, and I just wanted to do a real quick kind of introductory video, and then the next several videos will kind of have all the nitty-gritty that you're going to need to be able to do the lab, name compounds, and all that kind of fun stuff. So probably the most important thing for you to recognize, if you haven't recognized it already, is really important to decide whether or not you are an ionic compound or a covalent compound. And when we name things, or we turn names into formulas or formulas into names, that is also going to be the case, right? And so one of the most important things you can do is ask, is there a metal? And of course, being chemistry class, there's going to be one major exception to this rule, but just to start things off on the right foot, that is really the best thing that you can do. Ask yourself, is there a metal in this compound that I'm trying to make? Because that is going to be what 99.9% of the time gets you in either the ionic category or the covalent category. When you look at this kind of beginnings of a flowchart, this is really what I'm constantly asking myself anytime I am asked to do anything with compounds. And like I said, naming is no different. So if you have no metal, right, you're going to be over in this covalent category. And keep in mind that when we're looking at metals on the periodic table, metals are the majority of the periodic table, right? You look to the left of that metalloid line, and maybe I'll even put like a picture right here so it's a little bit clearer. You look to the left of the periodic table, and everything over there, with one huge exception, is a metal, right? So hydrogen is that exception. That turns out it's a non-metal that we have to put over on the other side of the chart for reasons I don't want to really get into now. But that's what we're going to do to determine whether or not we're in covalent land or ionic land. And I'm going to also just list off some of the major differences in terms of naming specifically having to do with covalence and ionics. And I'm going to draw it in red so that you can see how important it is, right? If you look at something and you're asked to come up with a name or a formula or anything else and it doesn't have a metal, what you will notice, or what you will need to learn to include, are prefixes, right? Prefixes are things that come before a particular name that indicate something about the number of them, right? And so a classic example, let's even write it down. A classic example of a covalent compound that I'm going to need to name might be something like carbon dioxide, right? We look at that, we see that di written right there, and so this guy right here, that's what I mean by a prefix. When you look at the actual structure of carbon dioxide, it's telling you that there's a single carbon bonded to two oxygens. So there is a name, there is a formula, right? And that's what we're going to be really talking about in this lab. In anytime you have to name something, is how do I kind of, go from a name to a formula to a name. And in covalent land, it's really easy as long as you recognize that prefixes always come to play. Technically, right, if we were being really proper, we should probably call this monocarbon dioxide, but there are, of course, in chemistry, these silly exceptions where sometimes you can leave a mono off. If I were you, I'd just always include the actual number of each of these, so I'd call this monocarbon dioxide. So what you're probably wondering is, well, 2, that's pretty easy, that's a di. What about 3? What about 4? What about 5? So what I'm going to do is include a resource guide right here that includes all the prefixes that have to do with those numbers. I'll do a real quick example. That's the beautiful thing about covalent compounds in terms of naming them. It really is straightforward if you just remember that you have to use prefixes. So let's say something, instead of an example of carbon dioxide. Okay, so let's take a formula and turn it into a name that is covalent, right? So something like, just something totally crazy here. Let's say I've got something like this. And honestly, I don't even know if that exists, but you'll see, how to name these things and how straightforward it really is. So you'll see, first of all, that you kind of have to figure out what the element is. So you do that treasure hunt on the periodic table, worst treasure hunt ever. Absolutely no payoff. And you find probably that P stands for phosphorus, right? notice that there are 4 of them. That's what the subscript means. So what we're going to call this thing, according to the guide I gave you for prefixes, that's called a tetra, right? Tetra means 4. So we're just going to simply call this tetraphosphorus. 10, right? That you'll look at that guide and you'll recognize that 10 means, or dec means 10. So this is going to be a dec, and you look up O on the periodic table and you'll see that it's oxygen, right? It turns out that oxygen just becomes oxide, right? That's something that's really, really common, that you just put the IDE ending on the end of anything. I guess technically it should be oxygenide, but nobody says that. If you do that, I don't care, right? It's just gonna, make me giggle a little inside because my mother didn't hug me. So this is tetraphosphorus decoxide. And it's pretty straightforward, right? If this was an 8, it probably won't surprise you to recognize that we're still going to call it a tetraphosphorus, but now it would be an octoxide. Right? And so it really is that simple. If there were 3 elements there, you just give the prefix that goes with that particular element and end it with IDE. Can't get much more simple than naming covalent compounds, but there's a huge but. I did it again. I said huge but. This side of the world, if you decide that there is a metal present and that it is ionic, if you use prefixes, you will 100% of the time get the question wrong, right? So that's why I put prefixes in red. Over here, absolutely no prefixes are allowed. Ionics, in a lot of ways, are a lot bigger of a pain in the butt in terms of naming and coming up with formulas. And you've probably seen a couple of examples of ionic compounds in like Lewis structures and ionic Lewis structures, where you've started to kind of recognize that you have to balance out the charges and stuff like that. But in terms of naming these things, that actually is going to be a pretty important part as well. But what we must never do, say it with me, never prefixes with ionics. Now you. I can't hear you. Louder. Now it's just awkward. Okay, so example here is going to be calcium bromide, and I believe it's the very first one on one of the lab activities that you guys are going to be working on. And our job here, if we're given a name, is to come up with whatever the formula happens to be. Right? And sometimes we're going to be given a formula and we're going to have to turn it into a name. Couple of things that you'll notice are similar with covalent. One is you'll notice that this ends in IDE, right? Turns out that IDE ending should be there, and if it's not, there should be a little red flag that we'll probably address in a future lecture video. But for now, right, IDE, that's just telling us, okay, everything's normal, this is a name, right? The IDE goes with, remember, this is the anion, right? The negatively charged thing gets the IDE. Another similarity is that you simply find the element, right? Just like we did before, right? And so we're going to obviously have a Ca in this particular compound and a Br, right? But you notice I'm not writing anything yet. That's because I have to be sure of something before I write the actual formula here. Notice that there are no prefixes here. It turns out that there are multiples of one of these things, but it is not told to me without me using a little bit of my brain. Right? And so what I suggest you do, the second that you look at something and decide there's a metal there and you're over here in ionic land, I immediately want you to make like a little work area, right? It always is going to require a little bit of work on your part to figure this guy out. So here is my work area, right? Here's the piece of paper that I'm going to use in order to figure out what the formula of this thing is. Well, first thing I'm going to do is I'm going to find it on the periodic table, right? What is the element that goes with calcium? Well, that's pretty straightforward. It's a Ca. What element do you think is a bromide? Well, it turns out that's the ionic version of bromine, right? We dropped the I on E, we added IDE. No big deal. But now what we have to recognize is before we write the formula, you always have a plus side of the world, which is the metal. You always have a minus side of the world, which is the nonmetal, right? there's the cation, there's the anion. You have to figure out what the charges is at this point. You absolutely have to figure out what the charges are at this point. Look at the resource guide that appears right here where I give you all the charges, or you could look at the periodic table and recognize everything is arranged according to charge on the periodic table. And what you would notice is that my calcium is a 2+. I would also notice that my bromine is a -1 or a 1-. There is a problem because this entire positive side here has to add up to the same amount of negative charge over here. What you'll notice is that we are unbalanced. If you look at some of the previous lecture videos, we do the Crossy trick, right? The Crossy trick is that thing that, you take the number that's with the charge of the metal and you drop it in front here, and then you take the number that's there and you drop it in front there. And it turns out that that would give us our answer, right? That's our answer to this thing. What is calcium bromide? Well, it's calcium with 2 bromides. Let's circle that in blue, right? So there is me taking the name and turning it into a formula. And you'll notice very clearly, I did not say calcium dibromide, right? The second you use di, that means you're in covalent land, and we're not there, right? That would actually be 100% incorrect, and may God have mercy on your soul, right? It's really that important, even though you're like, man, just grow your mullet and I want to end this term and get on with my life. I get it, right? But for now, you're my captive audience. So calcium bromide has that formula. So what about this work area, right? Well, what I want to make sure that I do at the beginning here is to communicate to you what exactly is this formula telling us. And if you've done Lewis structures, you probably are not going to be surprised what I write. But what it means is that I actually need 2 of these Br minuses in order to maintain the electrical neutrality of the entire system here, right? This has to be balanced. This side of the world has to add up to the same amount with the opposite sign of the other side of the world. Has to. If you don't do that, you will not have the right formulas. You're going to screw up your names, as you're going to see in just a second, right? And so this work area, even though most people are going to tell me to go float my boat, is absolutely vital for you guys to get all of these right. Another couple of things that we should talk about, and when you look at your lab, you'll actually see this, is that sometimes you're going to have to talk about, how do I name this? Well, this is called a calcium cation, right? There is only one calcium cation, so awesome, right? That we could talk about Ca2+, we could say calcium cation, and also the ion over here is Br1-, right? So we could call that the bromide ion right there. Sure, there's 2 bromides in this particular case, but we've got a bromide ion and a calcium cation. And sometimes questions will ask you to kind of parse out the charge of those different things when you see a formula. That's why it's so important that you guys actually write this down so you can kind of keep track of all the different parts depending on what kind of question some jerk like me wants to ask. What we're going to do now is I'm going to ignore the covalent side of the world because it's so much easier, right? Covalent, just use prefixes. The most complicated thing that can happen over on covalent land here is sometimes you drop the mono when it's the very first element. That's the only weird thing. Everything ends in "ide." You always use prefixes with that one exception. And so these are going to be no problem for us to name. Where the problems are going to lie is this little work area right here, right? And so let's take a look at that.